Hello students, now in this video let's start Karl Pearson's coefficient of correlation. Or it is also product moment correlation coefficient. It is a numerical measure of correlation coefficient or the correlation definition. Karl Pearson's correlation coefficient between two variables x and y, usually denoted by R, it is usually denoted by R, is a numerical measure of linear relationship and is defined as the ratio of the covariance between x and y to the product of standard deviations of x and y, that is R equal to covariance between x and y upon sigma x into sigma y, standard deviations of x and y, where covariance between x and y is what? 1 upon n summation xi yi, I goes from 1 to n minus x bar y bar. Now let's write one note. Correlation between x and x, what do you think what it is? Look at correlation between x and x. So let me put here the value. It will be covariance between x and x, and here also we get sigma x into sigma x. This is a variance of x upon, this is what? Sigma x square. Variance is also a square of standard deviation, so it will be what? 1. Also covariance measures the extent of extent of joint variation between x and y. Due to this property, of variance, covariance, a relative measure of correlation is defined using covariance. Also, covariance between x and y is negative. It gives there is negative correlation. Less than 0 means negative, so there will be negative correlation, because this is the standard deviation. The product of standard deviation will be positive. Here this is x and y. It is always positive square root of the mean of square of the observation minus the square of the mean of that observation. So here it is what? If it is greater than 0, then it is positive correlation. Okay. Now let us simplify this result, just like we have been simplified the result of covariance between x and y. We have R is equal to covariance between x and y upon sigma x to sigma y, where sigma x is what? 1 upon n summation xi minus x bar square, means the arithmetic means positive square root of arithmetic mean of the square of the deviations about their mean. It can be written as such. Similarly, sigma y is this, that can be written as such. Therefore, what is this R becomes? Now let me put the result of covariance also. What is R? R is equal to what then? Result of covariance we can put what? 1 upon n summation xi yi minus x bar y bar upon these results we can put. So it is square root sigma x into sigma y. The square root is here also, square root is here also. Let me take a combined square root. Okay, so it is 1 upon n summation xi square minus x bar square into, as such I have taken x root square root x square root y, so it can be written as square root x into y. Remember this. 1 upon n summation yi square minus y bar square. We can write it as such. Fine. Now here further it can be written as, this is 1 upon n summation xi yi minus x bar y bar as it is. Now this 1 upon n into 1 upon n, it will become 1 upon n square. That can be taken outside as 1 upon n. So what is left in a square root will be these things only. Here 1 upon n is multiple to this sum only. So let's multiply here by n also. That thing is also. Here we have taken 1 upon n common. Here also 1 upon n common as such. So in this bracket summation xi square minus n x bar square into summation yi square minus n y bar square. Okay, now this can be further written as, look at, this is further, it will be n times summation xi yi minus summation xi summation yi. What I had done here, upon n will be there, here also upon n will be there, it will become n square. Fine. So summation xi upon n, summation yi upon n, it will become n square. And so here also I have been adjusted n square. N square can be done by multiply divided by n will be there. Fine. And here also, if we here 1 upon n, here 1 upon n square, so that one of the n is get cancelled and it will become, fine. Now here at denominator, what can we write? It will be n into summation xi square minus summation xi whole square. Fine. Into n into summation yi square minus summation yi whole square. There is a difference between these two things. Remember, one of these is what? Summation of this yi square. We have to do a square first and then we have to add this part. Similarly, this one also. And here we have to do sum first and later on we are doing a square. These are two different things. Okay, remember them. These two things and these two things are similar to each other. So here this result we are using for calculating r. A simple thing is this. Using xi, look at, we have xi yi. Fine. So simply we have to find xi square yi square and their product is here. Already sum we are doing. So here we need sum of their product. Here we need sum of the xi, sum of yi. Here the sum of the squares of xi. Here sum of xi, sum of squares of yi and sum of yi. So this is a very simple result to use us. No need to find these differences and all. Okay. So here this form I am using what? R is equal to what? N into summation xi yi minus summation xi into summation yi upon square root of what? N into summation xi square minus summation xi whole square into n into summation yi square minus summation yi whole square. This one, this result for calculating r we are using further. This is a suitable form for calculation of coefficient of correlation. So now this form is more suitable for calculation or for calculate, more suitable to calculate the coefficient of correlation. Okay, remember this. Now further, let's see the limits for coefficient of correlation. Here the magnitude of r means coefficient of correlation gives idea about the degree of linear relationship between x and y, and the algebraic sign of R tell us the type, whether either it is positive or negative correlation. Between these two variables. Now, limits for correlation coefficient. Now simply let me give the limits for coefficient of correlation. Actually we have the proof of this one, but we won't prove this one here. We will simply see the limits. Karl Pearson's coefficient of correlation between two variables is numerically less than or equal to unity. Numerically less than or equal to unity. That is, modulus of R is less equal 1, or it can be written as -1 less equal R less equal 1. Means R lies between the interval -1 to 1. Here further we have to see the interpretation of R. Some general rules for interpreting the value of R. Interpretation of R, that is general rules for interpreting the value of R. Okay, let's see this. What are the rules here? So first rule, when R is equal to 1, it means there is perfect positive. Already we have seen this in scatter diagram. Perfect positive correlation between those two variables, obviously. Second, when R equal to -1, it means there is perfect negative correlation. Perfect negative correlation between these two variables. When r is equal to 0, it means there is no relation or no correlation between them. Okay, fine. Fourth, larger value of modulus of r indicates high degree relationship. While when mod of r is greater than 0.8, it means there is very high degree of correlation. Very high degree of correlation. Then next, when modulus of r lies between 0.3 to 0.8, in between these one, it means there is moderate degree of correlation. Then next, when modulus of r is less than 0.3, it means there is very poor or very poor correlation. Actually, the algebraic sign of r indicates whether the correlation is positive or negative. Whether the correlation is positive or negative. This is all about the theoretical part of Karl Pearson's coefficient of correlation. Next video we will see examples on them. Thank you.